Today's webinar is about establishing an effective defect management system to support TPM. Presenting the session today is Ross Kennedy. Ross is the President and Founder of CTPM, a team of business improvement coaches. Ross is recognized as Australasia's leading authority on total productive maintenance and CTPM's Australasian TPM lean approach to operational excellence. So let's get started with today's session, and I'll now pass you over to Ross.
Right. Good morning, everyone. For those who it is morning, and for our New Zealand friends, good afternoon. Welcome to our webinar for today, which is all about establishing an effective defect management system to support TPM. I've been visiting a few sites late last year, I guess the second half, who are going down the TPM site pathway. And one of the things I noticed was that they were struggling with their defect management systems or their approach of handling when defects were being identified and tagged, etc. So I thought it might be timely to do a webinar on that topic. So we're broken up into 5 parts. Where does defect management fit into the journey, TPM journey? Expectations of an operator supporting TPM, so what are we expecting to do? The role of a defect tag, the traditional work order system limitations, and how to develop an effective defect management system. But to start with, let's put into context where this all fits in. And I thought I'd start with the slide which we've used in previous webinars on challenges faced by Toyota when developing their TPM. And as we know, TPM is all about applying prevention at source to equipment. In other words, finding the small little problems at the earliest possible time. And what Toyota realized was that the best people to find the little things at the earliest possible time were the operators. The maintenance people still go and fix them, but the operators had to be trained and to identify and highlight the little things, the broken grease lines, for example, or nuts and bolts coming loose. So they had to create time to develop the operators so they could do this. They had to train all the operators to know what to look for. They had to change the existing equipment so it's easy for them to do it, so they weren't wasting time. You don't want to spend a lot of time doing it, but you want it to be very effective time. Any new equipment coming in, make sure it is what we call TPM friendly. Then create a maintenance support capability that can respond to these small little defects identified by the operators, rather than just rely solely on the traditional work order priorities. And finally, stabilize the production plan so you can do regular clean for inspection. Now, there's a fair bit in that, and you think, oh, why would we want to go and do all these things? What's the incentive? Well, I guess the incentive is it can have a big impact on the bottom line, it can have a big impact in the workplace, it can improve safety, improve quality, not to mention eliminate downtime. And as well as by fixing up, for example, the damaged grease lines rather than the failed bearings, your maintenance costs are going to come down substantially as well. So I guess there's a lot of evidence now out there, and we've certainly collected all this evidence over the last 20 years from clients who have achieved those results from applying TPM. So it is obviously a worthwhile activity. The thing that we want to develop, focus on today is that item 5, is how do we create a maintenance support capability that can respond to small equipment defects or problems identified by the operator, rather than rely solely on the traditional work order priorities. So that's really what we're talking about. So if we think about our hamburger for TPM activities and focus, the parts of the hamburger that we're really going to be talking about today are obviously operator equipment management, where we get the operators out there to do clean for inspections, etc., and also maintenance excellence management, which is where the maintenance people have to develop what we call a dual system for managing work, where they have their work order system and they have a defect management system, and that's really the topic of the day. I thought I'd throw this slide in as well. This was taken from, I think I last used this in a webinar on the 22nd of October last year, entitled Enabling Maintenance to Support TPM During Your Operational Excellence Transformation. So it's on YouTube if anyone wants to see it. But this is a slide that was put together by DuPont, where they realized or discovered through their research that there's actually specific stables of domain of behavior in organizations. And they're dictated very much by leadership and the way leadership measures and what systems leadership use. So for example, if you're in the fix it when it breaks stable domain, you would be in an environment where the key measure is response time. How quickly did it take you to get out there and fix it? And the systems would be very much orientated of making sure we've got plenty of spare parts. You never know when we're going to need them. And having our systems of having our tools on trolleys that can be moved around very quickly so we can get to the breakdowns. We move into planned maintenance, the traditional maintenance approach, where, well, we need different measures. We need to measure how often we do our preventive predictive. Are we on schedule with our preventive predictive work, for example? And our systems would be a work order management system. So we can track all the work we do and no job gets done without it going through the work order system. Then we move into TPM, and there's mechanistic and organic TPM, which we've talked about previously, but it's all about finding defects or avoiding defects. And again, to do that, you need different measures and different systems, like who's finding the defects, how many are we finding, are they being found by the operators or the maintenance people, etc. How well we're fixing them. And then we need a system or an add-on system to manage the defects, different from our work order system, to get that new stable behavior. So, and this is again what we'll be talking about, what that dual system is and why, etc. The last thing I just want to touch on was our model that we use now for the 10 integrated ingredients of TPM to try to get the message across, is that there is a pathway to follow. You need to do your preparation, you need to do your develop your maintenance capability, you need to develop your production capability before you get into the operator equipment management, which is the real, I guess, guts of what TPM is all about, of getting out there and getting the operators to identify all the defects and identifying the equipment problems at the earliest possible time. So what we want to talk about today is obviously the claim for inspection, but also the maintenance excellence, as I mentioned earlier, to develop a defect management system, because it's got to come from the maintenance people, because they're the ones who've got to run it. But it's got to be very much integrated with production. So this is where we start getting production and maintenance working in harmony. So claim for inspection, I think we all understand that one. The idea of operator equipment management, or some people call it autonomous maintenance, Japanese do, of course. The first stage, there's 4 stages to it, there's 7 steps all up. The first stage and the first 3 steps, and the very first step is identify and rectify equipment defects. So that's the starting point. So that's why you need to develop an effective defect management system before you even start into step 1. And that's why we normally make it an activity at a site to be done during their work area management activities, production work area management. While that's going on in the background, you start developing a defect management system that can be used when you kick into your clean for inspections. So just to refresh ourselves again on defects, what is a defect? Definition we use, the definition of an equipment defect is not just something that's broken and needs to be fixed, it's anything that could ultimately impact on the life of a component or part of the machine or equipment. Or in other words, anything that could lead to early or accelerated deterioration. And we use this model quite often where we talk about the path. It's almost like the 5 whys in reverse as to what is the pathway that leads to failure. And we're talking here particularly probably mechanical failure. So often before a machine fails, it will often perform poorly. Often before that occurs, you may get some indication through vibration, noise, heat, or fumes. And that will either be a consequence of 2 things, either natural deterioration or early or accelerated deterioration. I think natural deterioration, as we know, we put a pump in, say, or gearbox in for into our plant and we expect it to last for, say, 10 years, and after 10 years, it starts to make some rattly noises because it's sort of reached its natural life. And it's, you know, you've got 10 years out of it, great time to put a new one in. That's what we call natural deterioration. However, in a lot of cases, we go and put our pump in or our gearbox in and expect it to last for 10 years, and after 2 or 3 years, it starts rattling and making vibration and noises, and we have ourselves a problem. And that's what we call early or accelerated deterioration of our equipment. And that's the thing we want to stop from a TPM perspective, is to eliminate early and accelerated deterioration. Now, what do you find the first indication that that could be occurring or could be on the pathway to it is what we call an equipment defect. Why do we get that? Well, again, I guess our learning has been it's either lack of understanding or desire to care by either the people who go and design and procure or install the equipment, or most importantly, the way we operate it or maintain it. An example of lack of understanding or desire to care that could lead to early accelerated deterioration would be, for example, allowing contamination to build up over the equipment, over the gearbox or the pump, or having someone come along with a high pressure air line or high pressure hose and cleaning the thing down and blowing contamination into the seals that gets into the bearings. It could cause the problem. So that's what I mean by lack of understanding. So TPM is all about not only finding the defects and getting them rectified before you get the accelerated deterioration, but it's also educating and developing the skills of the operators to take more care of the equipment. Example of a defect. 2 defects in the photo. I'm sure you can all pick up on it. Those who've been to our training courses will know this one. We use it quite often. It's all got to do with the grease system. You've got a distribution grease system in the middle of the photo leading up to the bearings for the table rolls. There's a table roll system that's feeding into an aluminium rolling mill. Now, as you can see, that grease line has been come adrift from the connector, and the grease, instead of going into the bearing, is going onto the floor, onto the foundations. The other one's the same. Now, initially, when that happens first up, it's not going to cause a problem because there's still plenty of grease inside the bearing assembly, so everything will keep working. However, if it goes on for a lengthy period of time, that grease not being replenished will naturally deteriorate. That's what it's designed for. It's the sacrificial wear element is grease. It will deteriorate and you'll start having bearing problems, and you could have seizures and failures and very expensive repairs. So that's a simple example of the idea of finding a problem at the earliest possible time, and that's what we want the operators to be able to go along and say, hey, that is not right. Another simple example is just on a conveyor system or on in a food plant. And you can see here how the belt is tracking off. And the consequence is obviously spillage. Now they put a tray in there to help capture the spillage. But on the other side, if you look at the belt, it's starting to show signs of wear where it's rubbing up against the metal. So again, another example of something that's going to lead to accelerated deterioration of the belt. So that leads us into, so we understand defects and what we want to do about it. So that leads into, I guess, expectations of an operator supporting TPM. What do we want them to be able to do? We want them to be able to recognize equipment defects or anomalies at an early stage, right? Not when the thing's making a horrible noise, but when we've got that, oh, that grease line's not connected anymore. We better do something about it. Initiate and ensure rectifications are promptly carried out. So it doesn't mean they have to do it themselves, but to be able to go and get people on board to do the work rapidly. Understand equipment functions and mechanisms so they don't go and do silly things like blast high pressure water or air into seals, etc. Detect the causes of equipment defects or anomalies. So why are we getting these defects occurring? And be the ear and eyes to talk with the maintenance colleagues to work out how do we stop the defects from occurring. And that could be some form of identifying a design weakness in the equipment. Diagnose equipment problems at an early stage, so understand the functioning of the equipment so that we can diagnose issues effectively communicate equipment problems to maintenance, not just tell them that the machine's buggered, please come and fix it, and carry out minor servicing of the equipment where appropriate. They're the things that we expect from the operators. What we want to work on today is the first two: recognise equipment defects or anomalies. This is where a defect management system comes in, and initiate and ensure rectifications. Now, concerns of an operator supporting operator equipment management. And these are the things that we've identified in the workplace when we've been out there implementing TPM at many, many sites. How do I know if a defect has been identified by someone on another shift? You want me to go around and do an inspection on the equipment and write down all the defects? Yeah, okay, I'll write it down, but maybe the other shift has done the same thing. How do I know that they haven't done it? How do I know if the defect has been rectified? So, okay, I identify something. What tells me that without me going around and doing detailed inspections all the time? And how do I describe what the defect is if I don't understand the name of different components on the machine? We've seen many situations where people have written up that something is wrong. For example, the grease line is disengaged from the connector. Okay, put that in, goes in as a maintenance job. Someone else on the next shift comes along and goes, oh, lubrication systems not working on the table rolls. Oh, okay, another job, put it into the work order system. Third shift comes along and they have a different description again, and you end up with 3 work orders. Right, so all this led to the idea, the need for visual controls, or how do you make the whole concept of defect management highly visible? And that's where the concept of the defect tag came from. It is to give you that visual control that you have, one, identified it, and secondly, once it's been corrected, it's removed. Very easy for people. It doesn't matter if you can describe, you don't have to describe in detail what the problem is. It becomes obvious to the maintenance person once they see the tag that, oh, something's not right here. So it addresses a number of those issues I raised. So you can have very simple defect tags, or you can have more sophisticated defect tags. These ones you'll see in a lot of TPM textbooks, where you have a tag for maintenance and a tag for operator. In other words, if the operators can fix this problem, it's appropriate for them to fix it. Let's put a white tag on it, and the operators put it on their list. And if it's something that needs a maintenance tag, a maintenance intervention, well, we put a blue tag on. You've really got to be a little bit mature on this journey before you start rushing into those tags as being a learning, because what typically happens is the operators put all the blue tags on and the maintenance people put all the white tags on. Then they have a big fight about it, which we don't really want first up. So sometimes the very simple system is a good starting point. Anyway, once you get really mature at it, this is a 3-tag system that was actually developed by Duke in New Zealand, a big timber mill operation in New Zealand, where they had the situation of their equipment, their sawmill, had big saw blades spinning around and logs going through it. So it was obviously a very dangerous place. So they fenced the whole thing off, and no one was allowed anywhere near the actual moving equipment, obviously, while the mill was operating. And then when they had shutdowns, they would, open up all the fencing and people would go in and work on the equipment. And their challenge was that people couldn't sort of wander around and see where the defects were before the equipment shut down. So they had to, again, extend this visual concept. And what they did was they put a big map of the area on the wall, and they would pin the third part of the tag onto the map. So this was, we made this available to, for example, B&D Doors on their Bradbury line, which is where they make the panels for their panel garage doors. So again, you've got a lot of metal moving through the area, punching, pressing, bending, and whatever. And again, a lot of it's caged off. So they use that system there very effectively, because you can see from their initial claim for inspection, they certainly found a lot of defects. At the end of the cycle, end of the 12 weeks, they had certainly corrected a lot of those defects. This was excellent. And also, you'll notice on the diagram, they've left the pin on the board showing where the defect that was corrected came from. So that you've got like a history of where we have found defects in the past. So if they reappear in the same area, you can start asking the question, how come this is coming back? That's a use, again, using this whole thing being visual. So the next point, now we understand about defects and how to use defect tags and etc. and the purpose of them. Let's look at the actual work order system limitations. In a planned maintenance environment, as we said, work order system, no job gets done without a work order, spot on. But once you get into the TPM stable domain, it does have some serious limitations. Because what happens is the operator might see that we've got a damaged grease line, or as we saw in the photo of one that's disengaged. They might report to their supervisor that, hey, yep, we've got a problem here. Supervisors say, oh, we better put a work request in, so they put a work request in. And that goes into the maintenance people, and the maintenance then goes to the maintenance planner, puts it in the work order system, and then goes, right, every work order we have to give it a priority. So they would prioritize it based on the impact it has on the plant. They would then raise a work order that would go to the maintenance supervisor based on the priority system, and then the maintainer would be handed that to go and do the repair. So as you can see, it's quite a long-winded little process. Now, when we start prioritizing work orders, and I'll put up here excluding urgent safety work, which is always number one, obviously. Excluding that, if we use this diagram again, obviously if something's broken down, that gets the highest priority, especially if it's critical equipment. If the equipment is running poorly, in other words, it's running slower than it should, or having hiccups or things like that, or minor stops, you might get in and give that number 2 priority. If it's just making a bit of vibration, a bit of noise, well, obviously that's number 3. And by the time you get to early accelerated deterioration, which is often only picked up on by condition monitoring, that you know, the bearing has got a bit of vibration in it that is not obvious, but we can pick up on with our gauges and monitoring. And by the time you get to a defect, it's very, very low priority. So what actually happens is the defect becomes a bit like a very good bottle of red wine. The older you keep it, the more expensive it becomes. The longer you have a defect in the system, the work order system, the more expensive it is to repair it, because you've now got, instead of a grease line that needs to be reconnected, you may have bearings which are starting to deteriorate because they've been without grease for a period of time. So that leads into our main theme for today, which is how to develop an effective defect management system. But we need to recognise the challenge TPM places on our traditional work order system. And what we need to do is develop what we call a new system, or a defect management system. There needs to be some rules and some boundaries for this to work. And it's developing what are those rules, what are those boundaries, and every site will be different, obviously, but I can give you some examples of what some sites have used. So the thing we've got to recognise is that defect lists versus work request work orders. Work request work order systems are designed to address the discovery and rectification of early accelerated deterioration, vibration, noise, fume, poor performance, and equipment failure, like we saw in that diagram. A different system is required to address the discovery and rectification of equipment defects due to the magnitude involved, as you saw in that diagram from B&D Doors, and the need to prioritise differently. So, example, you may generate a standing work order each week for maintenance to rectify defects for, say, 2 hours on nominated equipment during the operator's regular clean for inspection. So by doing your regular clean for inspection, part of TPM activities, while that is occurring, you would have a maintenance person allocated to that machine or that piece of equipment. So you're capturing the cost of the maintenance labour to the work by having a standard work order saying we've just put 2 hours of labour into that machine. And then the boundaries could be all defects to be listed and managed on the operator's defect list. So when they issue a defect, the operators get the discipline to understand what's happening with their equipment by creating a defect list. Any defect requiring a registered spare part, in other words, something that's in the store that needs to be booked out through your maintenance management system, the rule might be that's got to go through a work order system because we're actually taking materials out of the store, so we need a work order to do that, to trace it. And that's understandable. Any defect requiring longer than 2 hours to rectify must go through the work order system because it can't be done during a clean for inspection, so it's going to be done at a shutdown time, and therefore you'd want it manageable during that period. Other than that, if it's within that criteria, it's like, let's tighten up this nut and bolt, let's go and fix up that grease line, you just go and get it done. It doesn't go through the work order. So any new system needs policies to support it. And again, this is an example of possible policies. Using the production area-based teams notice board for the focus of communication. So if you've got a TPM team, your operator equipment management team progressing, they would have a notice board, and we use that to communicate what's happening with our defects, and our defect lists on there. Defects are to be tagged and matched to a specific area with brief description, and enter the status on the list. Area maintainer to conduct daily review of new defects not able to be corrected by the production area-based team. So some little defects like a clogged up filter might be able to get cleaned by the operators, and that's fine. But anything that's listed that maintenance need to be looked at, you need to get your maintainer to go and see. And ideally, if they are finding defects on a daily basis, it needs to be done daily. If it's only happening initially on clean for inspections, it's critical at the end of the clean for inspection that the maintenance person looks at all the defects that have been identified and has a quick skin and look at them and say, okay, these ones are going to need work orders because they need spare parts. We put those aside. They will be addressed through the work order system. These ones we can do in future clean for inspections, and based on this list of 20 or 30, I'd say it's going to take us 6 hours to do all those. So there'll be 3 clean for inspections before we knock them all off. So everyone knows, oh yeah, okay, it's not going to happen tomorrow, but we know when they're going to get done, and we've put some sort of priority based on, okay, what we've seen during the clean for inspection. Maintenance work requests are only to be raised for defects that require a spare part or take longer than rectified in the clean for inspection time. Defect history recorded within the area and only copied to the planner if necessary, the maintenance planner. And area maintainer to regularly review the 4 lists that are generated by the operators during operator equipment management. And area maintainer to regularly or daily review the production area-based teams inspection charts. They're the clean for inspection charts developed by the operators. So this is an example of policies. Now, obviously, you have a flow chart of how to identify a defect, and that's just an example of the different options of how to manage a defect, which you would generate to support your new system. So just to finishing up, summary of our key learnings. TPM stable domains of behavior require different measures and systems to that of traditional planned maintenance. So if you are in the TPM stable, if you're heading for that, if you're trying to develop that, recognize you do need a different system. You do need a dual system, a defect management system and a work order system. Secondly, if equipment defects are not responded to rapidly, then interest or motivation in finding them will drop away rapidly. In other words, if operators don't see any reaction to the defects they're finding, and it doesn't mean you've got to fix them immediately, just being able to give them feedback to say, oh, this one's going to go to your work order system, we'll monitor that and give you feedback, or this one, yes, we'll do, and we won't get all these done next week, but we'll do them in 2 weeks' time or 3 weeks' time. People will be happy. People will know something's happening. Listing all equipment defect rectification jobs into your existing work order system will significantly overload its capacity. Again, if B&D doors, if we put all those, I think it's about 120 defects into their work order system, and as you saw, most of them were fixed up within a few weeks, you're just creating a hell of a lot of work for someone that doesn't really stop anyone. So, so there are learnings. How can we help you? I think you've all seen in New South Wales, if you want any help on the TPM journey or your improvement journey, We can get funding through the Smart Skills program, through the New South Wales government, which covers just about most of our costs to come in and help you, and your people get recognised with a unit or a couple of units in a Cert 3 or 4 in better system practices. So if you're interested in any of that, don't hesitate to give us a call. Yeah, we've got all the different manuals for doing operator equipment management, etc. And we've got this one. I realised that preparation for operator equipment management step 1, which goes through a lot of what I've just been talking about. There's a little booklet which we're happy to share with our members, and you can buy a copy of our webpage. The only thing was, when I looked at it last night, it was 2015. It's been around 5 years. Fair bit it was out of date, so I'm just going through it at the moment and updating it. We'll have that ready for you early next week if anyone is interested in that. With that, I think I've used up my time. Hope that's been of some value. Give you a bit of an understanding more about equipment defect management, and happy to answer any questions, or feel free to contact me anytime, either by email or mobile, and I can more than happy to answer questions for you. And have a great month of improvement activities. Cheers.
Okay, thank you very much, Ross. So as Ross said, if you have any questions, please press the raise your hand button now, or type your questions in the control panel box provided, and Ross will be happy to answer them. We'll just give you a minute or so. And while we wait for any questions, I just wanted to remind you that a link of today's webinar will be provided in a follow-up email to you later today. So please feel free to share it with your colleagues or watch it again. We'll just see. Doesn't seem we have any questions come through. We just got a little note here from Gilbert Ross saying thanks for a very well thought out presentation for an issue that we all face. So that was a nice little comment. Thank you for that, Gilbert.
Always appreciate your comments.
Yes, it doesn't seem like we've got any questions, so I think we'll wrap it up there. But if you have any further questions on today's session, feel free to contact us at any time, and Ross will be happy to get back in touch with you guys. And on behalf of everyone here at CTPM, thank you for attending today's session. We hope you enjoy the rest of your week.